Welcome back to another episode of Game Theory. We are still in Chapter 6. We just finished up an example of signaling using education in the job market as an example. One last insight before we do another example in the same theme. In our example here, education added no value to productivity. Nevertheless, education was still useful because it helped the employers separate the productive types from the unproductive types. Now, I'm not trying to say that education is useless for you. Rather, this shows the point by a different way. So, if education can still be useful, it does not enhance your productivity. If in the real world education does enhance productivity, then it's going to be even more useful. So let's go on and look at another illustration. So in the last example, we set the high and low wages in advance to try to find what are suitable levels of education that would separate high types from low types. Instead, now we're going to set in advance the education levels and solve for what wages will separate high types from low types. So let's say our productive types have the following payout function. That's going to be the square root of W minus 3 times their education. And the unproductive, or I'll call them the lazy types, that's going to be square root of W minus 7 times E. Same idea as before. The lazy type does not like going to school, so they get more disutility. They lose more from their payoff if they stay in school for a long time. So to know what is the outside option, let's say all of our types, both productive and lazy, can get a payoff of 9 by working for a different employer. So let's say if someone has an education of 3, what you're going to do is offer them the high-paying job. So you pay them WH dollars. So in contrast to our last example, instead of setting W and solving for E, now we're setting E and we're going to solve for W. If you have no education, we'll give you the worst job. So our goals are that we want everyone to be willing to work for us. So once again, the unproductive types still have a place. You just give them a job that is not as demanding. So those are the guys you hire for your restocking your shelves. You don't make them the surgeons. And you also want only the high types to do only the productive types to do the good job, and you want to separate them from the lazy types. And lastly, you're trying to do this while minimizing total wage costs. So there's going to be a range of values that satisfy these first two constraints. You want to pick the numbers out of that range that are cheapest for you, the employer. So the story's a bit different. Again, we invert it by solving for W instead of solving for E. The same ideas apply. We're going to have a participation constraint to make sure everyone wants to work for us. So let's write that down. So we said our productive types have this payoff. I want them to get the high education, high wage. So that's how much they get from working for you. But if they have this outside option, they could get a payoff of 9 by picking a different job. And then there's the similar participation constraint for the lazy types. Their payoff is square W minus 7E, and we're going to get them the low-paying job with low education. That also has to be at least as big as 9. Oh, there's a mistake here. What's the mistake? This should be a 7, not a 9. So we're told earlier that the high education EH is 3 and low education EL is 0. So we're going to plug that in. So we get square WH minus 3 times 3 has to be greater than or equal to 9. Which means that square WH minus 9 greater than or equal to 9, so square WH has to be at least as great as 18. So WH has to be greater than or equal to 18 squared. That's going to come out to 324. We'll do the same for EL. We said that the low education was 0, so that makes life easy. Square WL minus 7 times 0 is greater than or equal to 9. So that just goes away. Square WL greater than or equal to 9, which means that WL must be greater than or equal to 81. So those are two participation constraints to make sure that everyone is willing to work for us. So now we also need the incentive compatibility constraint. We want to make sure that the lazy types prefer the low wage, low education, and don't try to pretend they're productive types. We don't worry about the reverse problem. The productive types already want the good wage with the high education, so we're more worried about the lazy type pretending to be a productive type. So the lazy type does what we are trying to get them to do, that is, get the low education and low wage. They gotta be happier with that than if they had pretended to be a productive type. So you gotta set the wage or education accordingly so that someone who's a lazy type thinks that, say, going to med school isn't worth it. Because you don't want to have a lazy doctor. That's not good news. All right, so let's figure out how that's going to work. So our lazy type's payoff is square W minus 7E. So they get the low education, low wage, they square WL minus 7EL. And that's got to be at least as big as what they would have gotten if they go high education, high wage. So let's solve for what that would imply. So we said earlier that EH was 3 and EL was 0. So let's just go and plug that in. So we're going to find that square root of WL minus 7 times 0 has to be at least as big as square root of WH minus 7 times 3. So this just goes away. If the square root of WL has to be at least as big as square root of WH minus 21. So that's our incentive compatibility or IC constraint. And we're also trying to minimize overall labor costs. All right, so what comes next? We have this IC constraint, and then we have our two participation constraints. We have that over here. So one thing you do to minimize total labor costs, you pay the unproductive type the very lowest wage you can, such that they still participate. If that didn't work, you gotta try the other way and try to pay the high type the lowest they'd accept and see if that would work. But let's try this first. So you pay WL equals 81. So that means that you can plug it into our IC constraint over here and see what we're going to get. And we get that we have the square root WL has to be at least as big as square WH minus 21. So now you get square root 81 to be at least as big as square root WH minus 21. Square root 81 is going to be 9. We can add 21 to both sides, and we're going to get that 30 has to be at least as big as square WH, which means that square both sides, we're going to get WH has to be at least as smaller than 900. So you pay the high type a wage that's less than 900, then the lazy types will not pretend to be productive types. So what is the range of values for the high wage? It has to be less than 900 as established, but also has to be at least as big as 324. Well, that works. You can find numbers in that range. So our participation constraint said that WH had to be at least as big as 324. So any number in that range will work. To minimize total labor costs, what we'll do is pay him a wage of 324. So our solution comes out to the following. So it's another separate equilibrium. The different types, lazy and productive, have different outcomes, they have different education, and they get different jobs. So that wraps up that section. Join us for one last episode, and we'll finish up Chapter 6.